Hello and welcome to this video. My name is David Thorne, and in this video we're going to be talking all about generics, okay? And this is hopefully for you, it's going to be your end result, your end target, the goal, to be able to understand what this is doing and to be able to do it yourself, right? To be able to write protocols like this and to be able to understand how to implement these things, right? But by the end of this video or a couple of videos, I'm not sure how many videos it's going to go over right now. I'm 100% certain that I'm going to be able to explain generics to you in its entirety, all right? And I'm going to be able to help you to understand, to grasp generics, so you can go and read other documentations, you can understand what they're talking about, and then you can learn even more further than that. I can't teach you everything about generics because you need to understand it in your own time, but this is enough information that you need here to literally say, I understand generics, but I could be better at it, all right? Because that's what employers want to hear. I understand, I can read generic code, and if I don't understand it, I can learn about it even further. So with that said, let's scroll back to the beginning. Let's scroll back to the basics of this, and let's go back to the add function, all right? Let's go back to the add function, and let's say num1 and then num2, and this returns then an integer, and we know how to do this. It is then num1 plus num2, and then we get the results, and we say add num1, and then we say num2 is then 3, and we don't need to guess here, we're going to get 4, all right? But using type annotation, because we know that this is returning an integer, we are going to get 4 here, right? Which is all well and good. But what about if we want a decimal result? Okay, we now want 1.0 plus 3.3, right? Well, the compiler moans at this, cannot convert value of type double to expressed argument type integer, right? And you're like thinking, okay, well, it's all right. We can just change this. You know what I mean? It's nice and simple. I'm just going to say add double, nice and easy, and we'll just change this to double, and then we change this to add double 2, and done. We're finished, right? And they're like, oh, wait a minute, what about, we want float as well, don't we? We want floats. What about if we do float? That's no problem. We just make a new function, and then we can say here, and we can say float result. Do you know what I mean? It's not a problem, because you can just make lots of functions, and everyone is happy here. All right. But what about if you just want one function that? Because the most important thing here is this sign here is the plus sign, and the plus sign says, hey, I need the left and the right operand to have the same type, and I want to be able to add them together, giving it the result of this. Okay, well, if we take an integer, it will return an integer, and this plus sign, it knows what to do with that. So all we really care about is this plus sign right now, that num1, num2, and the result all are of the same type, right? Well, why don't we just say here instead, add, and then we're going to do these funny less than or greater than signs, and we're going to say num1 right here, and let's just say this is u, right? And num1 is got to be a u, and num2 has got to be a u, and we want to return a u as well. So now we're going to say here, num1 plus num2, and binary operator cannot be applied to 2 u operands. So you might be thinking, well, wait a minute, surely the add sign knows what the left and the right is. You know, they could just add the two together. Well, we've got to give the compiler a little bit more information than that. We've got to say, hey, this u needs to be able to implement this add. You know, so what we can do this by additive arithmetic here. And when we come and have a look at this protocol, right, we can see that it's equatable first of all, and it's got some properties here, and you can see here it's implementing the plus sign, right? And it's implementing the plus equal sign. It's implementing all of the signs that we need it to implement. So what we're saying here is that the add or the U, sorry, has got to implement this, all right? And so when we come to here now, let's just remove this num1 and num2, right? And we're going to have to just knock this out. And now you can see here, it's moaning about our function. And when we look at this, you can see here we get a result of integer, all right? Now, if we start putting 1.0 and 3, it's now saying it's a double, right? But because 3 can also be a double, it doesn't have to have a decimal place on it, because the first one has got a decimal place on it. And so the first U has said, hey, I am a decimal, and 3 can be a decimal because it's the same as 3.0. So it now makes the result as double, right? So, but we can remove this as once again, and we can say now result is now an integer. So this is the great thing about using generics, is we can tell it to have placeholders, and that's what we're doing with these angle brackets. We are telling it to use placeholders for it, but then we can also tell the compiler, hey, these items, these placeholders, they must conform to specific protocols. Now there are a few more things that we can do, but I want to keep it as simple as this, all right? But so this is the first video about generics, and if we come over to the side here, when you tap on this, you can see what this one protocol is doing, all right? And then when we come over to the generics, you can see here what it looks like. And this is something that what I want you to do is go away and try and see how many different types of functions you can create, right, that are generic. Because if you can grasp this, when we come back over to the entity store, this is doing nothing more than what this is doing. It just has a little bit more of a different syntax, okay? And but once you can understand that it's at compile time that the compiler looks at the different properties here, their implementations. Now let's remember that a generics or protocols, they don't care about the implementation. They're just telling you how it should look and how it should work, right? It's explaining its functionality, right? That it should have a function of get items that should return an array of a T, or a collection of T. It isn't telling you to have a collection of T. It's just telling you you've got to return one. And it's saying when you remove that, when you remove an item from the collection, right, using the identifier here, it should either throw or it should remove it, and updating it as well. And adding items as well should update this one entity, this one struct, all right? So you're not telling about the implementation, you're being declarative, right? When you implement it, this is being imperative. You're implementing all of the small working parts to it to make sure that the usage of this entity store conforms to everything that it says here. And so this is what the add function is doing here, right? It's saying, hey, as long as these two items here, they can conform to this plus sign, right, and this one protocol, I'll return you the sum of the two, not a problem, all right? So this is what I want you to take away from this. I want you to understand is that integers are structs, okay? And that is the implementation. This is where the implementation of the protocol comes from, all right? And we need both sides of the picture here. Is that here we are just talking about the protocol, what the blueprint looks like, but when we actually use it using type inference, that's where it looks at the implementation. It says, okay, the implementation conforms to the protocols, so you can use it. And both U's here are of the same type, even though when we said 1.1, that is then a double or a float, or whichever one you want to call it. But you see here we cannot have, because we are mixing up the U's here. We have a float, we have an integer or a float here, but when we use type inference, then the compiler is perfectly happy to say, hey, result is of type double. However, when we use type annotation, the compiler says, no, this can't work because we need to have U, and U, all of the same type. But right now we have float, integer, integer, or we have integer, float, float. And all the U's have got to match, all right? And this is not happening at runtime. This is happening at compile time. So when you see this, you know that your code is going to compile correctly if you've got all of the correct parameters, the associated types, the type aliases of everything correctly. And we haven't touched the type aliases yet, but in the next video we will. So please have a look at this and try and implement all of the other methods, the subtract, the multiply, the division, and so on, and the addition, with all the different types that you can use. And once you've got this, then move on to the next video. And the next video, we're going to get it's going to be a little bit more tougher to implement this. It's doable in one video for you to be able to understand it. It's very doable in one video. It takes only a couple of minutes, but for you to fully understand it, and we'll talk through it, because this is so important that you understand these things, because we're going to need it for future videos. If you just want to learn the basics of Swift programming, then we're done. We were done a long time ago, but we haven't scratched the surface yet of becoming a really good Swift developer where you can have a job and you can work with very complicated stuff and work for clients that need complicated calculations, they need complicated code, they need you to be able to implement that, all right? So with that said, I hope that you've got something out of this one video. I hope you've learned something from this one video. If you haven't, please go back and watch it from the beginning again. And if you still didn't on the second time, go back and watch it a third, fourth, fifth, sixth, and seventh time, because it could take a few times until you fully understand it, all right? The next video is going to be, the learning curve is going to go up relatively quickly. So stand by. And in order for us to really talk about collections, which we are now, we are fully on collections here right now, but we're using generics to talk about them, which is the best place to do it. So over the coming videos, you're going to fully understand sets, collections, dictionaries, and so on. But we're not going to teach you about those directly. We're just going to be teaching about generics and Swift programming language. With that said, thank you very much for watching. If you've got any questions, feedback, concerns, or anything like that, let's start a conversation in the comment section down below. Other than that, thank you very much for watching. My name's David Thorne, and I'll see you in the next video. Ciao, ciao, and goodbye.